morning, folks. Welcome back to Walter's Aircraft Works. It's May 5th, Cinco de Mayo. It's a rainy, a little bit windy, gloomy kind of day in Georgia, but it's always beautiful here in the shop. Episode 1, we finished up the adapter plate, or the bell housing part of the adapter plate. We're going to have to back up a little bit and work some more on this adapter plate. I've had a little bit of time to think about it. We talked a little bit about it at the end of episode 1 about maybe having to upsize this hole to accept the input shaft of the transmission, and the more I think about it, that's what we need to do. 2564, so it's a 10 millimeter, I believe, is probably really what it is. We'll probably use a 2564 drill bit, plunge down in here about 1/8 of an inch. That'll allow us enough space to stand the transmission up on the adapter plate like we did when we cut out the template. Once we get the transmission stood up on the adapter plate here and centered properly, we'll be able to use our center finders to mark these holes through the bell housing into the adapter plate, which then will give us a good indication, or a good indicator of where to drill the holes. So our bolt holes will match our adapter plate. We'll be able to bolt to our bell housing. There's also a couple of guide pins on that bell housing. We're going to try to drill those holes and get dowel pins installed as well. Once we get all that finished, then we'll start on our spacer rings. We'll probably find the centers, just using straight edge, going corner to corner, find the centers, drill the holes up to a 1/2 inch, which will match our hole here in the center of our bell housing adapter plate. Once the center's located, we can then line it up, both plates, and then mark and drill our holes for our mounting holes. The 4 mounting holes on this motor on the front face there is what we're going to use to attach our motor to our adapter plate. So we're going to have to locate and drill those holes, and then once those holes are drilled, located and drilled, then we can start figuring out how to chuck this thing up on the lathe and turn this from square stock into round stock, and also start worrying about coring out the center of them. The first dimension we're probably going to work with is this register mark right here on the motor, and then we'll probably increase the inside diameter of the hole a little bit bigger than that, so we have plenty of room for our shaft that's going to connect the motor to the input shaft on the transmission. So that's where we're at. We've got a lot of work to do here. Looking forward to all of it. So let's start by drilling up that hole on the adapter plate, the bell housing adapter plate, and locating those holes on the bell housing of the transmission. Alright, we're set up over here on the mill. Hopefully the lighting is going to be good enough. I've really noticed, this is my first forte into to doing a YouTube series like this, and really the first real attempt at videoing anything with any kind of precision, and it's more challenging than I thought it was going to be. Lighting is one issue. I've got pretty good lighting here in the shop, some good sized windows on the outside in the perimeter of my shop. 4 of these good sized windows, plus the windows there in the doors on the end, and lots of lighting on the overhead, 4-foot fluorescent lighting. But it's really evident when you have an overcast day like we do today, how much lighting affects this filming. So if it's not bright enough in here, I apologize. I'll keep trying to work to make these videos better, but it's the best we have right now. Hey, how did I index this hole in the mill? There's several different ways of doing it. This is kind of a not such a precise way of doing it. All I used was, it's a hole finder again, a 1/2 inch. I just lined it up in the hole of the transmission plate, and then maneuvered the bed of the mill until that punch slid in there evenly or easy without any force. You know, the machinists around the world watching this video are probably screaming right now, and you know, probably get some comments about a better way of doing it. I know there's dial indicators that you can chuck up in the mill and spin it around and work it down to you know, less than a thousandth of an inch or even more precise than that. But I don't have one of those, and I think this is going to be plenty good for what we're doing. I got the 25/64 drill bit chucked in here. I got my drill stop set to 1/8 of an inch. That should give us the clearance that we need to be able to attach this or to push this adapter plate up against the bell housing. So let's get it drilled. Alright, that worked well. Now we'll get it set up over on the sawhorse again with the transmission sitting up on top of it, and that'll allow us to mark the holes through the bell housing into the adapter plate. Alright, we're almost ready to move the transmission over and stick it on top of the adapter plate and mark back through the holes to locate connecting bolts, our bolts that are going to hold our adapter plate to the transmission. But there's a couple of holes here, the dowel pin holes, that we're not going to be able to come back through the back side and locate. They're blind holes. They don't penetrate all the way through the bell housing. They only, you know, they're cast in here and machined in here, but not all the way through. So I think I've come up with a solution to locate these dowel pin holes. We're still going to have to drill all the way through the bell housing, but with a smaller hole. And you know, the solution here, I think, is these little bullets that I've turned on the lathe. They're slightly smaller in diameter than the dowel pin hole itself. They slide in. I've turned them to a point, and they slide in far enough to go back a little bit shy of flush with the mating flange here. But the idea is to drill a hole, a small, like an 1/8 inch size hole, all the way through this dowel pin hole, come out the back side of the bell housing, then slide the bullet into the hole, probably use a little bit of grease on the bullet itself to keep it positioned in there, to keep it from falling out when I stand the transmission up on the bell housing. But once I get it positioned in the right spot, I can come back on the back side of it where we've drilled that small hole with a punch and just give it a good sharp tap. Should push that bullet out and make an indentation in our adapter plate exactly where that dowel pin hole needs to be. I also wanted to be kind of careful about how I drilled that hole bell housing. So I created really with the same stock that I cut the bullets out of. I just drilled an 1/8 inch hole in the center of this stock to help me keep centered up in that hole. So it should be able to drill straight on through and out the back side. Let's get it done. All right, we've got the other side to do. I'll do that off camera. Looks like that's going to work fairly well. All right, I got a little lubriplate grease on these bullets. I'm going to slide them in. Clean off the flange there. I think I'm going to take a little bit of Sharpie and just mark these areas. That one's not working so good. Let me see if I can find a better one. Yeah, that's better. Mark these areas. Let's see where the bolt holes are. There's one right here. And then I'll do the other two, and then we'll get it flipped up and get them marked. All right, I got it flipped over, and it dropped right in there. It looks like it's fitting real well. Kind of sized up the holes, and it's a little bit strange. There's some of them that take a 7/16 center finder, and the other one is a little bit smaller at 27. What is that? 27/64. You'd have thought the machining would have been a little bit better quality than that. I'm sure it took all the same size bolts. I'm sure it was a metric bolt from the factory. You know, maybe I should have metric hole finders, but I think this will do the trick. I got it centered up well on the adapter plate, and it looks like the input shaft dropped right in the hole, right where it should be. So I'm just going to work my way around it. I'm going to give it a nice brisk tap with the hammer. I don't want there to be any question about where the punch mark is. I'll also use my small punch here, which has seen better days. It's got a little bit of a hook to it, but I'm going to use it in these holes that we drilled to hit the top of those bullets and hopefully make a good mark in the adapter plate with those bullets. I'm going to be real careful about holding these center punches, the hole finders, holes. I keep calling these different names, and I can't remember exactly what they're called. Center finders. I'm going to make sure that they're as close to vertical as I can get them. I don't there is a little bit of slop to them, and that can obviously change the position of that hole significantly. So I do my best to hold them in the vertical position and work my way around, making sure that I've got the best fit in each hole. Well, there they are. Look like, well, it took 4 different size punches or center finders to fit on all the different holes. Let's see, there is what, 1, 2, 3, 6 holes total, plus the 2 dowel pin holes. So that ought to be plenty to take the torque. All right, so now let's get it separated, see what those look like, and then we'll have to drill the holes. Well, you can see that it did a good job marking them. I did pretty good. Well, the Sharpie worked really well as far as creating a contrasting color, except for right here where I didn't do a very good job of getting the Sharpie in the right spot. Oops. Well, let's see. Should have been up there. Yeah, well, I screwed that up. Oh well, still got a good divot there, so it'll be easy to find, easy to locate. The bullets seem to work really well. Next thing to do, we'll need to put this plate back in the mill, drill these holes, and boy, I should have thought of this to begin with. Should have put these dowel pins in first, put it back on the bell housing, and then mark these holes. Boy, that would have been the smart thing to do. Oops. Well, let's work on putting these dowel pins in and then matching it back up and see what we have from there. All right, I think we need to make some dowel pins here. I don't have the original, so we'll just have to produce some on the lathe. It won't be that big of a deal, be fairly quick and painless. Unfortunately, I don't know what the dimension is, and my tool to measure inside hole diameter is too big for this hole, so this is the smallest one I have. We're going to have to make the machinist mad all over the world again and use the inside or measure it with my Chinese calipers, which is really kind of maybe an educated guess, or as in the aviation world as we call it, a wag. But I think we can get close enough. We're not looking for a super close tolerance fit here. We just want something that snugly fits in there, that doesn't fall out, won't move around, and we don't want to have to drive the hound out of it either to get it in. But let's take some dimensions and then we'll get over to the lathe and get to work. All right, 433 thousandths is what it mic'd out to be. Looks to me, from my decimal equivalent chart, that's an 11 millimeter pin is what I'm sure what was in there. And I don't have an 11 millimeter drill bit. Probably could order one, but looking at the decimal equivalent chart, 7/16 is just a few thousandths of an inch larger than that. So I think what we'll do is we'll we'll turn these pins down to 433 thousandths, and then set them in the bell housing and drill the holes in the adapter plate to 7/16. Going to give us, like I said, a couple thousandths clearance fit on those holes, but I think that's going to be good for what we're doing with it. Don't think it needs to be any tighter than that. So here we go. We got set up on the lathe. This is my lathe. The first time I think you all have seen it, at least with a close picture, and I love it. It's a great machine, donated to me by a friend of mine. That he received it from a friend of ours who passed away, his brother-in-law, and great guy, and I really appreciate it. I use this machine just like the mill on a daily basis. Love it. They're both great machines, and a very generous donation from Michael. So it's a Supermax 1338, which means that a 13-inch swing, and the ways are 38 inches long. I got the stock chucked up in my 3-jaw vise, or a 3-jaw chuck. This is the same material that I use to make those bullets. Just some mild steel, turns real well. I think it's going to do good for those dowel pins as well. Yeah, I'm not going to spend a lot of time showing you how to use a lathe. There's plenty of people out on the internet that do a great job of that. A-Bomb 79, I believe it is. Tubal Kane is a great guy to go to learn basic knowledge on a lathe. A-Bomb is a little bit more advanced. There's several people that are a lot better on these machines than I am. I'm kind of a hack. I get the job done, and I enjoy doing it, but I don't do it for a living, so it's not my forte. I think I get the job done, and I enjoy it, but don't follow what I do on this lathe, because I might lead you. I might be pointing you in the wrong direction. So if you want to learn how to work a machine, work a lathe, go out there on the internet and find somebody else that really knows what they're doing, and watch some video. That's what's great about YouTube, is there's plenty of people out there that can show you how to use these machines, people that do it for a living, people that are really great craftsmen, and that have basically donated their time to teach us how to do this stuff. So I'll show you what I'm going to do. I'll probably fast forward through some of this stuff, but we'll show you the basics and how I'm doing it, and hopefully that'll work. All right, got the machine set up with a insert bit in, or a raised in insert bit, and my dial caliper set up and zeroed out. Looks like we need to take off about 300 thousandths before we start really kind of honing in on it. So we'll whittle off 300 thousandths fairly quick, and then we'll start slowing down a little bit and kind of easing in on our dimension. And I'll go back and forth several times, resetting the calipers and making sure that everything's set where it needs to be set, as we ease in on the final dimension. Alright, we're showing 82 thousandths to go. I'm going to peel off another 50 thousandths. Let's see. Yeah, right there, 50 thousandths. Actually, I dialed in 25 thousandths, but since it's cutting off both sides of the stock, it's 25 on each side of the stock, which is 50 thousandths. we should be right around 32 thousandths left to go. And let's see, it's showing 36 right there. I don't know if you can see that. And 40 thousandths there. So you got about a 4 thousandths cone going on, due to, it's the rigidity of the material. There's enough tool pressure here at this end where it starts that it's actually bending the stock out slightly, a couple thousandths of an inch, and as it works towards the chuck, it gets harder and harder for it to bend the stock out. So that's what causes this cone shape. I'm going to turn the camera off here. I'm going to try to freshen up this tool just slightly, and then maybe we'll change some speeds and try to reduce some of that coning as we narrow in on our final dimension. Alright, I freshened up the cutting tool and rechecked the dimension in the bell housing, and we're looking good. We got about 40 thousandths to go on the wide end and about 34 thousandths or so on the end closest to the chuck. So hopefully we can take that coning out. We're going to slow down the feed rate on the tool, and I think I'm going to speed up the spindle speed just a little bit, and we're also going to reduce the amount of material that we're taking off with each pass as we kind of creep into our final dimension. So hopefully all that combined will help us reduce that coning to a minimum. Well, that worked fairly well. It certainly improved the finish of the pin, and we're down to about 2 thousandths difference between the far end and the close end. So we're going to take another pass here. We got about 22 thousandths to go here. We're going to take a little less of a cut this time. We're going to try 5 thousandths. Go ahead and dial 5 in. That's slightly more, maybe 6, so 5 thousandths, which will be a 10 thousandths total pass, which will be about half of what we need to cut off. So let's take another pass at that, and then take some more dimensions. Alright, the finish is looking real good on it. I dialed in about 8 thousandths of an inch, actually 4 thousandths of an inch, so it'll be 8 thousandths total. Looks like that's going to be pretty close. We're still about a thousandths difference between the close end versus the far end, but I think this is going to be good. We can probably polish the rest of it out, but I think this should be the final pass. Well, there you see it. I think you could see it. We're showing a thousandths under on this end and a thousandths over on this end. So I'm going to work it with a piece of emery cloth a little bit on this end, and then we'll figure out what's the length that we need, and then we'll trim them off. We're still showing 1 under on that far end and it's 0 on the close end. It's hard to put the material back on with the emery cloth, but it's easy to take it off with it. So I think that's going to be good. I'm going to chamfer this edge, and we're going to have to go back over to transmission to figure out how long we need them, and then we'll part them off and flop them back around in the lathe here to chamfer both edges on them, and then should be done. Alright, the depth of both of those holes looks like 5/8 of an inch, and our adapter plate is made out of 5/8 of an inch stock, but we don't really want the dowel pin to stick all the way through the adapter plate either. I think we want to drill that to be a blind hole as well. If we drilled it all the way through, there's a possibility of those dowel pins working their way out forward and coming out. So I think if we cut those pins off to be, well, about an inch, that should leave plenty sticking out to go into our adapter plate. Let's go cut 2 1 inch each. All right, I'm going to chamfer this end first with a file, and then we'll set up with the parting tool to cut off our first pin. I need to freshen up that parting tool. It's pretty rough. Be right back. All right, both pins are cut to length. I've slid them in here. A little bit short, I think, on the dimension. Probably has to do with just miking the inside holes here with the way we did it with the calipers here. It's not a real accurate way of checking the dimension on the inside hole. So we're a little bit too loose. I'd rather it was kind of a tap-in fit. But I think it'll be okay. What I'll wind up doing, I think, is running the knurling tool on this end of the pin, which will raise the edge just a little bit, and then we'll be able to tap them in with a little bit of a little resistance, and that'll hold them in place. Besides that, I think they'll be fine. We probably could even Loctite them in with the same results. You just really need to hold them in place so they don't fall out. Once we get the adapter plate on there, it's not going anywhere. It's going to do what they're really intended to do. So next step is to drill the adapter plate, and then we'll refit it back on the bell housing here. Check our marks here that we marked with the center finders. Make sure we're in good shape there, and then drill those holes. I did wind up knurling these pins, which just gives it a little bit of a raised surface here, which should add a little bit of resistance to hold the pins into the holes. Let's tap them in. That should do nicely. All right, we're set back up in the mill, getting ready to drill our holes for our dowel pins. And I used a really scientific method for determining whether the mill was lined up with our little divot here. I used this little tiny hole starter just to give me a pretty sharp point to lower into the divot. And you work the table back and forth on the y-axis here to get it centered up into our dimple there. It's all set, table's locked down, and now we're going to use a little bit bigger hole starter to start the hole. Then we'll use several different drill bits to bring us up to our final hole size here. And we're not going to plunge all the way through. We're going to only go in about 1/2 of an inch, so leave about 1/8 of an inch. Probably the point of this big drill bit will be pretty darn close to sticking out the other side due to the taper there, but it'll be fine. You know, worst come to worst, we could drill all the way through it. That's not the end of the world either, but we're going to try not to. All right, like I said, I want to plunge in about 1/2 of an inch, so I've brought the drill down and touched the back side of this ruler here, and then set the drill stop at 1/2 of an inch. It's actually about 1/16 over 1/2 an inch to kind of taking into account the taper there on the end of the drill bit. So let's see if this works. All right, same process with this drill. All right, same process, final bit. Okay, let's give it a good chamfer here so it'll help us line the pin up with the hole. All right, that looks pretty good. One more hole to do. All right, let's see. Let's see if the plate fits. Perfect. Those dowel pins probably could have been a little bit tighter going into that adapter plate as well as into the transmission bell housing, but hey, you know, I think it'll do fine. We're going to put 6 bolts through it, and a combination of those 6 bolts and the 2 dowel pins, I think we'll be in good shape. Stood the transmission back up on the adapter plate and took a flashlight, looked down through the holes through the bell housing at the dimples that we made in the adapter plate with the center punches, and it looks like everything's still really lined up. I'm going to go ahead and go with those dimples that are already made, move it back over to the mill and drill the holes. I think I'm going to use a 7/16 bolt. For some reason, a couple of the holes, I think there's actually 3 of them. This is a 7/16 center finder. It drops in this hole nicely. This one, it's just shy of going in. The same over here and back here. So three total that the 7/16 hole finder will not go in, and then 3 that it does go in. So I think what I'll do is aim for using 7/16 bolts in these holes and just open these 3 up just slightly to accept that 7/16 bolt. I'm sure originally it was some kind of metric size, but I'm going to use, I think, probably a grade 8 7/16 cap bolt is what I'll wind up using on it. Well, I chamfered the holes on the front side just using the same chamfering tool I used in the mill. I just chucked it up in my handheld drill here and just put a light chamfer on the outside just to take the burr off. All right, so let's put a transmission on the bell housing and see how we did. All right, nice tight fit. Here's the 7/16 hole finder, center finder. We use it to check the holes. Let's hope they lined up. Hey, that works good. Let's see. This is one of them that the bell housing will need to be opened up a little bit. So, it's close. For some reason, well, it's probably the draft on the casting of this bell housing. I'm assuming it's flared out here and then necks down. I guess that's probably the draft they need. Tight. Same deal. This is the starter bolt. Held the starter in place, so that one goes all the way through. That's a nice fit. Same with the bottom. This is starter. Nice fit on that one as well. So just like we thought, the holes lined up perfectly. The 3 that originally wouldn't take the 7/16 punch still don't take the 7/16 punch. So no surprise there. I think we did real well. I've been promising you that we'd get started on the spacer rings, and that's coming up next. Let me finish reaming those holes and get set up to do the spacer rings, and we'll move on.